Something happened in the night sky recently that hasn't happened in decades. 4 planets lined up across the horizon in a single sweeping arc, visible to the naked eye, stretching from one edge of the sky to the other like someone had drawn a line straight through the solar system. People pulled over on highways to stare. Astronomers posted about it at 2 in the morning. Phones lit up with photos that somehow never quite captured what the eye could see. And then, almost as quickly as the conversation started, it went quiet. The news cycle moved on. Scientists gave brief, careful statements, and millions of people were left wondering the same thing. Is that it? 4 planets line up like that and we just move on? Because here's the thing. The official explanation is simple enough. Gravity, orbital mechanics. The planets all orbit the Sun on roughly the same plane, and every so often from our vantage point on Earth, they appear to gather in the same stretch of sky. Nothing to see here. Beautiful, yes. Meaningful? Not scientifically. But that explanation, while technically accurate, leaves out a staggering amount of context. It leaves out what ancient civilizations believed these alignments signaled. It leaves out the data anomalies that have appeared during previous planetary alignments that nobody in mainstream science has fully explained. It leaves out the classified research programs that have studied gravitational resonance between planetary bodies for decades. And it leaves out the question that keeps coming up in serious astrophysics circles, usually in footnotes, usually in language designed to be ignored. What if the positions of the planets aren't just the result of physics, but also a reflection of it? A mirror showing us something about the deeper structure of space itself that we don't yet have the tools to understand? This video is about what the alignment actually means, not what they told you. All of it. Let's start with what you actually saw or would have seen if you stepped outside on a clear night and looked west just after sunset. 4 planets. Venus, Mars, Jupiter, and Saturn, each blazing at different brightnesses stretched across roughly 110 degrees of sky. Venus was impossible to miss, the brightest object in the night sky after the moon, a hard white light low on the horizon. Jupiter, enormous and steady, sitting higher up, cream-coloured and unwavering. Mars, distinctly reddish, a warm ember between them. And Saturn, further along the arc, softer, golden, almost understated compared to its companions. What made this particular alignment unusual wasn't just that 4 planets were visible at once. That happens with some regularity. What made it unusual was the geometry. They were aligned with extraordinary precision along the ecliptic, the imaginary line in the sky that traces the Sun's apparent path through the year, and they were doing it at a time when the Earth's own position put us in an almost perfect observational window, meaning the alignment wasn't just real in the sense of orbital mechanics, it was geometrically striking in a way that alignments often aren't. Astronomers who study planetary geometry professionally noted that the spacing was, in one researcher's words, aesthetically perfect, which is a strange thing for a scientist to say, and worth paying attention to. Now, here's where the history becomes important. Because human beings have been watching planetary alignments for at least 5,000 years, and across nearly every civilization that left records, these events were treated as anything but ordinary. The ancient Babylonians built the most sophisticated astronomical observation system of the ancient world, not for curiosity, but for prediction. They believed the positions of the planets were a direct communication from forces beyond human understanding, a kind of language written in orbital mechanics. They had names for every type of alignment. They kept records spanning centuries, and when multiple planets gathered in the sky, they prepared, not out of superstition. Out of pattern recognition. The Babylonians had noticed something over generations of observation. Major alignments seemed to precede major events. Floods, famines, the fall of dynasties, the rise of new empires. They didn't fully understand the mechanism, but they were meticulous observers, and what they observed was a correlation so consistent that they built their entire state religion around tracking it. The Egyptians did something similar, but with different architecture. The Great Pyramid at Giza is oriented to the cardinal directions with an accuracy that modern surveying equipment would struggle to replicate. The interior chambers align with specific stars at specific times of year. The entire structure, many researchers now believe, was designed as a permanent record of celestial geometry, a way of encoding the positions and cycles of the heavens in stone so that information would survive anything. War, flood, the death of a civilization. Why would you do that unless you believe those positions carried information worth preserving forever? The Maya, working independently on the other side of the world, developed a calendar system so precisely calibrated to planetary cycles that it could predict celestial events centuries into the future. Their long count calendar, which you've probably heard of in the context of apocalyptic predictions that didn't come true, was not a doomsday device. It was a record of what the Maya believed were recurring cosmic cycles, periods of time defined by the positions and interactions of the planets, during which certain types of events, certain energies, certain possibilities became more or less likely. 3 completely separate civilizations, no contact with each other, all arriving at the same basic conclusion. The positions of the planets matter. They carry meaning. They predict or perhaps influence events on Earth. Modern science dismisses this entirely, and there are good reasons for that dismissal. The mechanisms proposed by ancient cultures were wrong, or at least unverifiable. Astrology, as popularly practiced, has no scientific basis. The specific claims made about planetary alignment causing earthquakes or influencing human behavior have not survived rigorous testing. But here's what's more interesting and more troubling than a simple dismissal. Modern science hasn't fully explained why the dismissal is so clean, because there are things we know, verified by measurement, that should make us at least pause before closing the door entirely. The gravitational influence of the planets on Earth is real. It is small, but it is real. The Moon's gravity visibly deforms the planet's oceans every single day. Jupiter, the largest planet in the solar system, is massive enough that its gravitational influence is measurable across enormous distances. When multiple large planets are on the same side of the solar system, the combined gravitational effect on the Sun, and through the Sun on every other body in the system, is measurably different from when they are scattered. We know this. We can calculate it. We do calculate it because it matters for things like spacecraft navigation, where tiny gravitational nudges compound over billions of miles. So the question isn't whether planetary alignments have physical effects. They do. The question is whether those effects are large enough to matter for anything on Earth. And the honest answer, the one you won't find in most popular science writing, is we don't fully know, because we haven't looked hard enough, because the funding to look hasn't been prioritized, because the question sits too close to astrology for comfort, and scientists quite reasonably don't want to be associated with astrology. But that discomfort has a cost. It means there are genuine scientific questions sitting unanswered, not because the answers don't exist, but because asking is professionally risky. And this brings us to the classified research. In the 1960s and 1970s, during the height of the Cold War, both the United States and the Soviet Union ran research programs studying the potential effects of gravitational and electromagnetic influences on human cognition and behavior. The American programs are partially declassified now. They were mostly focused on things that sound more like science fiction than science. Remote viewing, psychic phenomena, the possibility that human consciousness could be influenced by external fields. Most of it didn't pan out. But buried within those declassified documents are references to something that has received almost no public attention. Studies on what researchers called heliospheric modulation, the idea that the configuration of the solar system, including the positions of the planets and their combined gravitational influence on the Sun's magnetic field, might affect geophysical and even biological processes on Earth in ways that existing models didn't account for. The studies were inconclusive. Inconclusive is not the same as negative. It means they didn't find what they were looking for, but they also couldn't rule it out. And in the decades since, several independent researchers working outside mainstream institutions have found correlations between major planetary alignments and increased solar activity, between solar activity and disruptions to Earth's magnetic field, and between disruptions to Earth's magnetic field and everything from unusual weather patterns to subtle changes in human neurochemistry. Each link in that chain is individually controversial. Taken together, they form a hypothesis that the scientific community has collectively decided not to pursue, not because it's been proven wrong, because it's inconvenient. Now let's talk about the Sun, because this is where things get genuinely strange and genuinely documented. The Sun's magnetic field operates on an 11-year cycle. Every 11 years, the Sun's poles flip. The north magnetic pole becomes the south becomes the north. During this transition, solar activity increases dramatically. More sunspots, more solar flares, more of the coronal mass ejections that can knock out satellites and power grids when they hit Earth's magnetic field. This cycle is well established. What is less well established and considerably more interesting is what drives it. The standard explanation is that it's purely internal. The Sun's own plasma dynamics, its differential rotation, the churning of magnetic fields within its outer layers, these generate the cycle from within. External influences are negligible, but a significant minority of solar physicists, people with serious credentials at serious institutions, have spent careers arguing that the external explanation is incomplete, that the gravitational influence of the planets, particularly the large outer planets, subtly modulates the Sun's activity cycle in ways the standard model doesn't fully capture. The lead researcher in this area spent decades at a major European space agency before publishing work suggesting that the alignment of Jupiter, Venus, Earth, and the other planets with the Sun's equatorial plane creates a kind of tidal effect on the Sun's outer layers, and that this tidal effect correlates with the timing of solar activity peaks and troughs, with more precision than the internal model alone can explain. His work was published in peer-reviewed journals. It was also aggressively criticized. Not all of the criticism was scientific. Some of it was about what the implications would mean, that the planets are not just passive objects orbiting a static star, but active participants in a dynamic system, one where position and geometry actually matter to the behavior of the Sun itself. If that's true, even partially true, then planetary alignments are not just beautiful accidents. They are moments when the system's internal dynamics are being pushed in a particular direction by the combined gravity of multiple large bodies simultaneously. Moments when the Sun is being, in a very precise physical sense, pulled. And if the Sun is being pulled, the solar wind is affected. And if the solar wind is affected, Earth's magnetosphere is affected. And if Earth's magnetosphere is affected, well, everything that depends on Earth's magnetic field is affected. Which is, depending on how you measure it, everything. Let's go deeper on the magnetic piece, because this is where the science becomes almost philosophical. Earth's magnetic field is not just a navigational convenience for migrating birds and compass users. It is the shield that makes life on this planet possible. Without it, the solar wind would strip away the atmosphere over geological time. The magnetic field deflects charged particles from the Sun, funnels them toward the poles where we see them as auroras, and maintains the conditions under which complex chemistry, the kind that produces DNA and proteins and cell membranes, can operate stably. The field is generated by the movement of liquid iron in Earth's outer core. It is not fixed. It fluctuates. Over millions of years it reverses entirely just like the Sun's field, with the north magnetic pole becoming the south. We know from the geological record that these reversals happen, and we know they are associated with periods of reduced field strength when the planet is temporarily more exposed to radiation from space. Here's what's interesting in the context of planetary alignment. The geological record of magnetic reversals shows a pattern. The reversals do not happen randomly. They cluster. They come in groups separated by periods of relative stability. And those clusters correlate imperfectly but consistently with periods of elevated solar activity, which correlates, according to the controversial planetary researchers we just discussed, with periods of strong planetary alignment. The chain of causation, if it exists, would go something like this. Planetary alignment affects the Sun's activity cycle. Elevated solar activity affects Earth's magnetosphere. Prolonged magnetospheric stress affects the stability of the geomagnetic field. It would be a slow process. Geological timescales slow. Not something you would notice in a single alignment or even a single human lifetime, but something that, accumulated over millions of years of periodic alignments, might leave a fingerprint in the rock. And the fingerprint appears to be there, tentatively, controversially, in ways that have not been fully investigated because the question is too dangerous professionally to ask loudly. What does this mean for the alignment that just happened? Probably nothing dramatic. A single alignment, even a geometrically striking one, is unlikely to be the trigger for anything you would notice. The effects we're describing are cumulative, statistical, operating on timescales that dwarf human history. But here's why it still matters. Because understanding that the solar system is a dynamic, interconnected system, not a collection of isolated balls orbiting passively around a fire, changes how we think about everything. it changes how we think about the search for life elsewhere. For most of the modern era, the search for life on other planets has focused almost exclusively on the star. Is it the right size, the right temperature? Is there a planet in the habitable zone at the right distance? But if planetary geometry matters, if the configuration of other planets in a solar system affects the behavior of its star and the stability of the conditions on its inner worlds, then the question of habitability becomes enormously more complex. A planet in the right zone around a good star might still be periodically bombarded by elevated radiation if the giant planets in its system align in ways that drive solar activity up. Or it might be unusually protected if those giants are arranged in configurations that dampen solar variability. We have not systematically studied this. We are only beginning to catalogue the giant planets in other solar systems well enough to even ask the question. It changes how we think about ancient observation. If the Babylonians and the Egyptians and the Maya and dozens of other cultures we haven't mentioned were picking up on something real, even if they interpreted it through a mythological framework rather than a scientific one, then their records are not just historical curiosities. They are data. Millennia of observation by people who had strong practical incentives to get the correlations right, recorded in documents we still have access to. The idea that those records might contain signal worth extracting is not fringe speculation. Several serious archaeoastronomers have spent careers trying to do exactly that, and the resistance they encounter from mainstream academia says more about the boundaries of intellectual comfort than the quality of their work. And it changes how we think about ourselves, not in a mystical sense, in a purely physical one. Human beings evolved on a planet embedded in a solar system. Our biology is calibrated to the conditions of that planet, its cycles of light and dark, its seasons, its magnetic field. The idea that the larger dynamics of the solar system might influence those conditions, and therefore influence us, is not inherently more strange than the idea that the moon's gravity influences the tides. It is a matter of scale and mechanism. The scale is larger than we are comfortable with. The mechanism is not yet fully understood. But not yet understood is not the same as impossible. There's one more piece of this that we need to talk about, and it's the piece that made the scientists go quiet. In the days following this most recent alignment, there were several notable geophysical events. A significant earthquake in a region that had been seismically quiet for years. An unusual spike in solar activity that was not predicted by the standard solar weather models, and a brief but measurable fluctuation in Earth's magnetic field that was picked up by monitoring stations on multiple continents. Each of these events has an official explanation that does not reference the planetary alignment. The earthquake is explained by tectonic stress that had been accumulating for decades. The solar spike is explained as a random flare from an active sunspot region. The magnetic fluctuation is explained as routine variation in the magnetopause, the boundary between Earth's magnetic field and the solar wind. These explanations are plausible. They are not necessarily wrong. But they are conspicuously isolated. Each event is explained in its own box, with no acknowledgement that three unusual geophysical events occurring within a narrow window around a major planetary alignment might be worth mentioning in the same sentence. The scientists who might make that connection publicly are quiet, not because they're afraid of a conspiracy, because they're afraid of something far more mundane, being dismissed, being associated with a hypothesis that sounds like astrology. Watching years of credibility evaporate in the time it takes for a tweet to go viral. Science advances when researchers ask dangerous questions. The history of the field is full of people who were right about things that were professionally ruinous to be right about. Continental drift was heresy for decades. The idea that bacteria cause stomach ulcers was laughed out of meetings before it won a Nobel Prize. The person who first suggested that the mass extinction 66 million years ago was caused by an asteroid impact was told it was not a serious scientific hypothesis. The question of whether planetary alignments have measurable effects on the solar system, on Earth's geophysical systems, and on the conditions for life is a serious scientific question. It is not astrology. It is not mysticism. It is an inquiry into the dynamics of a complex gravitational system that we happen to live inside, one that we are, as a species, only beginning to understand. The alignment you saw in the sky was not just beautiful. It was a reminder that we are not observers looking at the universe from outside. We are inside it, embedded in it. part of a system whose full dynamics we cannot see clearly because we're too close, too small, and perhaps too protective of the mental models that make us feel like we already know how it works. 4 planets lined up in the sky. Gravity did the geometry, and somewhere in that geometry, there may be information we haven't learned to read yet. The ancient observers knew something. The medieval monks who tracked planetary cycles for centuries knew something. The indigenous astronomers who built stone circles and medicine wheels oriented to celestial events knew something. Not the specific mechanism, not the clean mathematical model, but the instinct that the sky was worth watching carefully and over long periods of time because it was telling you something. Modern science gave us the mechanism and took away the meaning. What we are slowly, awkwardly, in the teeth of significant institutional resistance beginning to recover is the possibility that the mechanism and the meaning might not be as separate as we assumed. The planets will align again. They always do. The question is whether, the next time it happens, we will have built the tools and the courage to actually ask what it means, in the full scientific sense of that word, to look at the geometry of the solar system not as a fixed background to human history, but as a dynamic ongoing influence on the conditions that make human history possible at all. That's the conversation that isn't happening. That's the science that isn't being funded. That's the question that was briefly on millions of people's lips when they looked up at the sky and felt correctly that what they were seeing mattered. It does matter. The full story of why is still being written. But the fact that 4 planets lined up in the sky and we were here to see it, that we have 5,000 years of records from people who watched the same sky and drew the same instinctive conclusion, that the physics allows for effects we haven't fully characterized, that the geophysical events following the alignment were never placed in the same frame as the alignment itself. That's not nothing. That's the beginning of a question. And the questions we refuse to ask are always the most interesting ones. So let's actually follow that thread. Because the interesting part isn't that ancient cultures watched the sky. The interesting part is what they built to do it. When you look at the distribution of megalithic structures around the world, something becomes immediately obvious that mainstream archaeology has been reluctant to say plainly. These structures are not randomly placed. They are not positioned for convenience, for water access, for defensive advantage. They are positioned for sight lines. Specific, precisely calculated sight lines to specific points on the horizon where specific celestial events occur at specific times of year. Stonehenge is the famous example, but it's actually one of the less impressive ones in terms of precision. The heel-stone alignment to the summer solstice sunrise is real, but it's relatively coarse. What makes Stonehenge interesting is the broader landscape it sits within. There are more than 900 stone circles in the British Isles alone. They form a network, a distributed observational system spread across hundreds of miles of landscape, each site calibrated to local topography, all of them oriented to the same set of celestial events. The effort required to build even one of these structures was staggering by any reasonable estimate. Moving multi-ton stones across dozens of miles, shaping them without metal tools, erecting them with enough precision that the alignment holds across centuries of subtle ground movement and atmospheric distortion. People who needed to spend most of their time securing food did not do this casually. They did it because they believed the information they were collecting was worth that cost, worth the cost of human lives lost in the construction, which you can be certain it was, worth the cost of community resources redirected away from immediate survival needs. What information was worth that? The honest answer is that we don't fully know. The people who built these structures left no written records. What we have are the structures themselves, the alignments they encode, and the astronomical events those alignments target. And what we find when we map those targets systematically is that the builders were primarily interested in a specific set of phenomena: solstices, equinoxes, lunar standstills, and the rising and setting points of certain bright stars at certain times of year. The lunar standstill is the one that most people haven't heard of, and it's the one that's most relevant to what we're discussing. While the sun rises and sets at varying points along the horizon across the year, moving between its solstice extremes in a smooth cycle, the moon's behavior is considerably more complex. The moon's rising and setting points also shift, but over an 18.5-year cycle rather than an annual one. At the extremes of this cycle, called the major and minor lunar standstills, the moon rises and sets at the most extreme points on the horizon it ever reaches. The difference between the standstill extremes is significant, many degrees of arc on the horizon, dramatic enough to be unmistakable to a careful observer. Many megalithic sites are aligned not to the sun but to the lunar standstills. This matters enormously because the lunar standstill cycle is subtle. You cannot determine its periodicity from casual observation. You need multi-generational records. You need people passing knowledge across at least 3 generations, watching and noting and comparing, before you even know the cycle exists, let alone determine its length. The fact that Neolithic builders were designing permanent stone structures to mark the standstill extremes means they had already solved that problem. They had maintained coherent astronomical records for at least 30 years, probably longer, using whatever encoding system was available to them before writing existed. We don't know what that system was. We don't know how the knowledge was stored and transmitted, but the stones tell us it was. The precision is the testimony. And the pattern extends far beyond Europe. The Chaco Canyon great houses in the American Southwest contain windows and doorways that align to solstice and equinox sunrises and sunsets with engineering precision, in a desert landscape where construction was a brutal expenditure of human energy, and the nearest timber for building supports had to be transported over 60 miles. The Great Kivas at Chaco are aligned to mark the extremes of the lunar standstill cycle, just like the megalithic structures in Britain. Separated by 8,000 miles and multiple millennia of independent development, these two cultures arrived at the same celestial preoccupation, the same observational priority, and built permanent structures to serve it. The standard interpretation is that these alignments served ritual purposes tied to agricultural cycles. Knowing when the solstice was coming told you when to plant, when to harvest, when to prepare for winter. This is probably partly true. But it doesn't explain the lunar standstill alignment. The lunar standstill has no direct agricultural relevance. The moon doesn't control growing seasons. An 18-and-a-half-year cycle has no practical agricultural application because it spans multiple generations of crops and farmers. The extraordinary effort put into tracking and marking the lunar standstill cannot be explained by farming utility. It has to be explained by something else. By the belief that the moon's position at its extreme points mattered for reasons beyond agriculture. The question of what those reasons were is not one that mainstream archaeology has seriously pursued, because the honest answer would require seriously entertaining the possibility that ancient cultures understood something about the relationship between celestial geometry and terrestrial conditions that we have not yet reconstructed. There's a researcher who spent 2 decades mapping the full corpus of megalithic alignments across Western Europe, and came to a conclusion that was received with a mixture of fascination and discomfort in the academic community. He found that the distribution of aligned structures, when plotted against the complete set of celestial phenomena they track, shows a statistical coherence that cannot be explained by coincidence or independent local variation. The sites are not just individually aligned, they are systematically organized as a network, as if the people who built them were collaborating across enormous distances and multiple generations on a single, coherent observational program. His work raised an obvious and uncomfortable question. What were they observing, and why did they need a networked system to do it? Single sites at single locations would be sufficient for tracking annual solar events. A distributed network suggests you're trying to triangulate something, to get measurements from multiple vantage points that you can then combine to extract information that no single location can provide. What kind of celestial observation requires simultaneous measurements from multiple locations across hundreds of miles? The honest answer is, the kind where what you're measuring is not just the position of the object in the sky, but the relationship between that position and conditions on the ground below it. If you believe that celestial geometry affects terrestrial events, and you want to characterize that effect rigorously rather than just record it anecdotally, you need distributed observation. You need to know not just that the moon was at standstill when a flood happened in one valley, but whether the same flood occurred or didn't occur in valleys whose relationship to the moon's position at that moment was geometrically different. This is not primitive superstition. This is systematic inquiry conducted with the tools available. The tools were stone and naked eye observation rather than computers and telescopes, but the methodology, the attempt to correlate celestial position with terrestrial effect across a distributed network of observation points, is recognizable as science. It is the practice of controlling for variables, something we consider a modern innovation, performed in stone 3,000 years before anyone wrote down the word variable. The fact that we haven't taken these records seriously as data, that we've filed them under ritual and moved on, may be one of the more significant intellectual mistakes of the modern era. Let me give you a specific example of what taking them seriously might look like. The standing stones at Callanish, on the Isle of Lewis in the Outer Hebrides, are aligned in a way that has puzzled researchers for decades. The main alignment is roughly north-south, which is unusual. Most megalithic alignments target the solar or lunar extreme points on the horizon, which in the latitudes of Britain tend to be northeast-southwest or southeast-northwest. A north-south alignment has no obvious solar or simple lunar explanation, but at the latitude of Callanish, the moon at its major standstill does something it does nowhere else in Britain. It skims along the southern horizon for nearly an hour before setting, staying so low that from certain vantage points it appears to travel along the tops of the hills rather than above them. To an observer standing in the central ring at Callanish, the moon at major standstill appears to rise from behind a distant hill range called the Sleeping Beauty, which has a profile that resembles a reclining human figure, travel across the horizon and set between the standing stones of the main avenue. This happens once every 18.5 years. It requires multi-generational knowledge to predict it, and the site is aligned to it with extraordinary precision. Someone built a massive stone monument to mark an event that occurs once in a human generation, at a location that offers a unique visual geometry for that event available nowhere else in the British Isles, and did so with engineering precision that required sustained communal effort spanning multiple generations. The ritualistic explanation says this was ceremonially important, which is circular. It says the ceremony was important because it was a ceremony, which tells us nothing. The observational explanation says this site was chosen and built because the geometry of the moon's behaviour at this location at major standstill was measurably different from its behaviour anywhere else, and whoever built this was interested in capturing that difference in permanent form. Why? We don't know, but the fact that the question has not been asked with sufficient seriousness is itself a problem. Let's move from what ancient cultures observed to what they believed they understood. Because there's a tradition that connects the dots between planetary position and terrestrial effect that most people are aware of only in its degraded popular form. Astrology, as you probably know it, is newspaper horoscopes and personality archetypes and weekly predictions that could apply to anyone. It is not, to put it charitably, a rigorous system. It has been extensively tested, specifically its claims about personality correlating with birth month sun sign, and it fails every test cleanly. This is not controversial. The scientific community is right to reject it. But the history of astrology is considerably more interesting than its popular form, and the version of astrology practiced by Babylonian astronomers, by Hellenistic scholars, by medieval European universities where it was taught alongside astronomy as a sister discipline, was not about personality types. It was about correlation, specifically the correlation between planetary positions and terrestrial events, primarily political, climatic, and epidemiological events, not individual personalities. Medieval and Renaissance astrology was genuinely attempting to be predictive in a statistical sense, not in the sense of knowing what would happen to any individual, but in the sense of identifying periods when certain categories of events became more or less likely, when particular planetary configurations historically preceded epidemic outbreaks, when certain alignments correlated with political instability, when the approach of Saturn and Jupiter into close conjunction, which happens roughly every 20 years, had historically preceded the deaths of rulers or the collapse of institutions. The Jupiter-Saturn conjunction claim is worth dwelling on, because it has been studied independently by researchers who had no interest in rehabilitating astrology, and found something they couldn't quite explain away. The 20-year Jupiter-Saturn conjunction cycle is real. The two largest planets in the outer solar system align from Earth's perspective roughly every 20 years due to their orbital periods. This has been tracked and noted since Babylonian times. What is harder to explain is the observation, noted across multiple independent historical analyses, that major political transitions in historically powerful states, the deaths of leaders, the collapse of governments, the sudden termination of dynasties, cluster around conjunction periods in a way that appears non-random. The most famous example in American history is something called the Tecumseh Curse, or the 0-year curse, the observation that every American president elected in a year ending in 0, starting with William Henry Harrison in 1840, died in office, until Ronald Reagan broke the pattern. The years ending in 0 correspond almost exactly with the 20-year Jupiter-Saturn conjunction cycle. This is not something astrologers made up to fit the data. The correlation was noted before anyone systematically connected it to Jupiter-Saturn. The question of why a 20-year political mortality cycle would align with a 20-year planetary cycle has not been seriously investigated by anyone in a position to fund serious investigation. The easy dismissal is coincidence. 6 American presidents across 140 years is a small sample. The confidence interval on 6 data points is enormous. This could absolutely be coincidence, but it sits alongside a large number of other historical correlations involving the same 20-year cycle. Correlations that appear in unconnected historical records from different continents and centuries. And the question of mechanism, if the correlation is real, is actually not as mysterious as it sounds. You don't need mystical influence. You need something much simpler. A 20-year cycle in some geophysical variable, perhaps solar activity, perhaps geomagnetic variation, perhaps something in the cosmic ray flux that modulates Earth's cloud cover and climate, that affects the conditions under which human societies experience stress. Stressed societies experience political instability. Political instability tends to claim the leaders who were in power when the stress peaked. That is a mundane and fully materialist explanation. It requires no magic. It requires only that the solar system's dynamics have periodic influences on Earth that we have not yet characterized, which we already know is at least plausible. The reason this explanation doesn't get traction is not that it's wrong. It's that admitting it might be right requires re-evaluating several centuries of very confident dismissal, and institutions, like people, find that difficult. There's a related thread that runs through the history of epidemic disease, and this one is particularly uncomfortable because it involves data collected during events when accurate recording was a matter of survival. In 1918, the influenza pandemic killed somewhere between 50 and 100 million people, a range of estimates that tells you something about how overwhelming the event was. The standard epidemiological story is that a novel influenza strain emerged, the war created conditions for rapid spread, and a combination of dense troop movements and limited medical understanding produced catastrophic mortality. This is accurate as far as it goes. What the standard story doesn't discuss is that several researchers in the immediate aftermath of 1918 noted something strange about the pandemic's global distribution. It appeared almost simultaneously on multiple continents in populations that had no plausible route of person-to-person transmission contact with each other. The timing was too synchronized for a conventional spread model to explain. Populations in remote Pacific islands showed infection at nearly the same moment as populations in European cities, weeks before any ship that could have carried the virus would have arrived. The researchers who noted this anomaly proposed several hypotheses. One of them was that the triggering factor was not the person-to-person transmission of a virus from a single origin point, but rather the simultaneous activation of a latent pathogen by some external environmental trigger that affected susceptible populations globally at the same time. This hypothesis was not taken seriously in 1918 for reasons that are partly understandable. The germ theory of disease was relatively new and urgently needed to be defended from the alternatives that had dominated medical thinking before it. Proposing an environmental trigger for epidemic activation sounded uncomfortably like a retreat from germ theory toward environmental mysticism. But the question of why major epidemic events sometimes show globally synchronized onset faster than person-to-person transmission can explain has not gone away. Several modern epidemiologists have noted the same anomaly in other historical epidemics, and have proposed, very carefully and with considerable hedging, that changes in solar activity affecting cosmic ray flux, and therefore atmospheric ionization, and therefore the viability of airborne pathogens might be a partial explanation, not instead of viral transmission. In addition to it, a trigger that activates a pathogen system that transmission then carries forward. If that hypothesis has any validity at all, then the state of solar activity at the moment a novel pathogen emerges matters enormously to how that pathogen behaves globally. And the state of solar activity is, at least partially, influenced by the configuration of the planets. Again, the chain of causation is individually controversial at each step, Taken together, it forms a hypothesis that is either profound or wrong, and we cannot tell which because we have deliberately avoided investigating it. The year 1918 falls in a period of elevated solar activity near the maximum of solar cycle 15. The specific months of the pandemic's most explosive spread correspond to a period of pronounced geomagnetic disturbance driven by elevated solar wind. These are facts, not interpretations. Whether they are relevant facts is precisely the question that no one with funding and a laboratory has been willing to seriously ask. Let me step back from the historical and epidemiological threads for a moment and come at this from a different angle entirely, because there's a physics argument that most people haven't heard, and it's the one that, to my mind, makes everything else more plausible rather than less. The argument is about resonance. When two oscillating systems are coupled, meaning when they exchange energy with each other, they tend over time to synchronize. This is a well-established physical principle, first described in the 17th century, and since confirmed in systems ranging from pendulum clocks to brain cells to population cycles in ecosystems. It's called entrainment, or synchronization, and it happens reliably whenever coupling is present and the systems have compatible frequencies. The solar system is full of coupled oscillating systems. The most famous examples are orbital resonances, where the gravitational interaction between two bodies in orbit around the same star causes their orbital periods to lock into simple integer ratios. Jupiter's 4 largest moons are locked in resonance with each other. For every orbit the outermost makes, the middle one completes 2 and the innermost completes 4. This is not a coincidence. It is the result of gravitational coupling over billions of years, gradually synchronizing orbital frequencies until they locked into a stable pattern. Orbital resonances are not exotic. They're extremely common in planetary systems. Our own solar system is full of them. Neptune and Pluto are in resonance. Several groups of asteroids are locked in resonance with Jupiter. The orbital periods of Venus and Earth are very close to a 13:8 ratio. The question of whether this near resonance is coincidental or the result of gradual synchronization is genuinely open. Now here's the implication that is rarely stated directly. If the planets of the solar system are coupled gravitational oscillators that have been exchanging energy for 4.5 billion years, and if coupled oscillators tend to synchronize, then the current orbital configuration of the solar system is not random. It is the product of billions of years of gravitational dialogue between the bodies in the system. The positions of the planets relative to each other right now are not arbitrary. They reflect a history of interaction, a history of mutual influence that has gradually organized the system into its current state. And if that is true, then when the planets align in particularly geometrically coherent configurations, those configurations are not accidents. They are the moments when the resonant structure of the system is most clearly expressed. When the gravitational coupling between bodies that has been operating for billions of years simultaneously produces its most coherent pattern. Whether such moments have effects that extend beyond orbital mechanics into the biological and geophysical systems that exist within this gravitational web is exactly the question that the planetary researchers we discussed earlier have been asking, and exactly the question that the institutional discomfort around astrology has made it professionally dangerous to investigate. But notice, nothing in this argument is mystical. Nothing requires forces beyond gravity. Nothing proposes mechanisms outside known physics. It requires only taking seriously the idea that a complex coupled gravitational system, observed at a moment of particularly coherent geometric expression, might be doing something measurably interesting. That is a respectable scientific hypothesis. It is not astrology. It is not numerology. It is gravitational physics applied to a scale and complexity that our current models have not adequately addressed. There's a direct practical application of this that has gotten almost no attention, despite the fact that it matters for something people care enormously about right now: climate. The standard model of Earth's climate system treats solar activity as essentially constant, with minor variations on the 11-year cycle that are too small to explain any of the major climate trends we observe. The variations in solar output across the activity cycle are about 0.1%. The models say this is too small to drive significant climate change. The attribution of 20th and 21st century warming to human greenhouse gas emissions is based partly on the elimination of solar variability as a sufficient explanation. This is probably correct in its broad outline. Human greenhouse gas emissions are the dominant driver of current warming, I'm not questioning that, but the solar variability models used in most climate reconstructions are based on the 11-year activity cycle alone. They do not incorporate the longer period modulation of solar activity that the planetary researchers are arguing exists. The roughly 170-year Jose cycle, named after a mid-century researcher who first identified it, is the period over which the combined gravitational influence of all the outer planets on the Sun's centre of mass completes a full pattern. It is a real, measurable, astronomical period. Whether it affects solar activity in ways that affect climate is, again, contested. But the historical climate record contains fluctuations on timescales that are difficult to explain with greenhouse gas concentrations alone. The medieval warm period, when temperatures in parts of the northern hemisphere were comparable to today's, cannot be explained by greenhouse gases. The Little Ice Age, which lasted roughly from the mid-14th to the mid-19th century, and was associated with reduced solar activity during periods like the Maunder Minimum, shows a correlation between solar output and temperature that the current models treat as coincidental rather than causal. The Maunder Minimum is particularly striking. Between about 1645 and 1715, sunspot activity almost completely stopped. For 70 years, the sun was unusually quiet. This period corresponds almost exactly to the coldest decades of the Little Ice Age, when rivers in Europe that don't freeze today froze hard enough to hold markets, when harvests failed repeatedly, when the social stress of a colder climate contributed to the religious and political upheavals of the 17th century. The correlation between reduced solar activity and reduced surface temperatures in the northern hemisphere during the Maunder Minimum is documented in the climate record. What is less documented is whether the Maunder Minimum was a random fluctuation in solar behaviour or part of a longer period pattern driven by planetary configuration. The Sun was in a particular phase of the Jose cycle during the Maunder Minimum. It is in a somewhat different phase now. Whether that difference affects solar behaviour in ways that matter for climate is a question the major climate modelling centres have not incorporated into their standard scenarios. This is not a licence for climate denial. The current warming is real and primarily human-caused, but the climate system's full behaviour across centuries and millennia, the pattern of natural variability within which the human signal is embedded, may be significantly driven by solar dynamics that are themselves modulated by planetary configuration in ways we haven't adequately characterised. Understanding that full pattern matters for projecting future climate, for distinguishing the human-caused signal from the natural background, and for understanding what the climate system would be doing in the absence of human intervention. The planetary researchers are not saying human-caused warming isn't real. They're saying the natural background against which it operates is more structured, more driven by a coherent solar system dynamic than our current models assume. And if they're right, our climate projections for the next century are based on an incomplete picture. That claim has not received a fair hearing, not because it has been falsified, because it is inconvenient in a political climate where any suggestion that natural factors contribute to climate variability gets weaponized by people who want to deny the human-caused warming signal entirely. The science gets caught in the politics, and genuine questions go uninvestigated because investigators fear their work will be misused. This is a pattern worth naming. It appears in multiple domains of inquiry we've touched on. The aversion to investigating solar system dynamics because the question sounds like astrology. The aversion to investigating solar climate links because the finding could be misused by climate deniers. The aversion to taking ancient observational records seriously as data because it risks appearing to validate pseudoscience. In every case, the aversion is driven not by scientific evidence, but by the social and political context surrounding the question. Science is supposed to be immune to this. In practice, it never fully is. The funding structures, the peer review system, the institutional incentives around publication and citation, all of these create pressures that shape which questions get asked. It's not corruption. It's a structural feature of how human institutions work, but it means there are entire domains of legitimate inquiry that are systematically underfunded and understudied because they are adjacent to things that are embarrassing or politically inconvenient. The history of the solar system's influence on Earth's biological and geophysical systems may be the clearest current example of a domain where this structural avoidance is causing measurable scientific harm. Let's talk about consciousness, because this is where the conversation gets genuinely uncomfortable, and also where the most interesting recent work is happening. The field of neuroscience has spent the past several decades building increasingly detailed maps of the brain. We know which regions activate when you experience fear, when you recognize a face, when you make a decision. We can watch in real time as neural circuits fire and networks form and dissolve. The technology is astonishing. The resolution of our current brain imaging capabilities would have been considered science fiction 30 years ago, and yet. The hard problem remains. The hard problem, as the philosopher David Chalmers named it in the 1990s, is the question of why physical processes in the brain produce subjective experience at all. Why does the firing of neurons feel like something? Why is there something it is like to be you, rather than there simply being a complex information processing system operating in the dark? This problem has not been solved. It has been avoided, primarily by claiming it is not a real problem, that subjective experience is either identical to or fully explained by physical brain processes, and that the apparent mystery dissolves once you have a complete enough physical account. Some of the most prominent neuroscientists in the world hold this position. It is respectable. It is also, to a significant number of philosophers and physicists, demonstrably insufficient. The logical gap between a complete description of brain processes and the existence of subjective experience is not closed by making the description more complete. It is a category difference, not a gap of detail. The reason I'm raising this here is that consciousness, whatever it is not electrically or magnetically isolated from the environment. The brain operates through electrochemical processes that produce electromagnetic fields extending beyond the skull. These fields are weak. But weak is not the same as irrelevant, especially in a context where we're asking about the influence of external, electromagnetic and gravitational fields on biological systems. Human brain cells have been shown, in laboratory conditions, to respond to extremely weak external magnetic fields, fields far weaker than the fluctuations in Earth's geomagnetic field associated with solar wind disturbances. The cell-level response is real and documented. Whether it scales up to affect cognition, mood, or behavior in meaningful ways is where the evidence gets thinner and the controversy gets louder. There is a body of epidemiological literature linking geomagnetic storm activity to increased rates of psychiatric emergency room admissions, to increased incidence of cardiac events, and to disrupted sleep patterns in populations not otherwise exposed to any identified environmental stressor. This literature is methodologically uneven. Some of it is strong, some of it is not. The studies that are strong enough to take seriously have not been replicated with the consistency needed to drive mainstream clinical awareness. But here's what's notable. No large-scale, well-funded effort to definitively resolve this question has been made. There have been dozens of smaller studies conducted by researchers at the margins of their respective disciplines, none of whom has had the resources to design and execute the kind of prospective longitudinal study with sufficient sample size to settle the question. The question remains open not because the answer is clearly no, but because no one with sufficient resources has decided the question is worth answering. The reason connects back to everything we've been discussing. The geomagnetic field is influenced by solar activity. Solar activity may be influenced by planetary configuration. If human neurological and cardiovascular function is sensitive to geomagnetic variation, then the chain connecting planetary alignment to human health is not severed at any point. It may be attenuated at several points. The effect of planetary alignment on solar activity may be small. The effect of solar activity on geomagnetic disturbance is real but irregular. The effect of geomagnetic disturbance on human physiology may be small. Small effects multiplied through a chain of steps can produce either very small effects or surprisingly significant ones depending on the specifics. We do not know which applies here because we have not looked with sufficient rigor. The ancient cultures that built their entire civilizational infrastructure around tracking the sky were not tracking it to understand gravity or orbital mechanics. They were tracking it because they believed the sky was telling them something about conditions on the ground, including conditions affecting human health, human mood, human social stability. They were wrong about the mechanism. They were using mythology to describe what we would now describe as the electromagnetic and gravitational dynamics. But the instinct that drove them to watch and record and build permanent structures to mark the patterns they found is not obviously wrong. The instinct that there is a connection worth understanding is not primitive. It is an empirical observation dressed in the only conceptual language available to them, We have better language now. We have better tools. What we may not have is the courage to ask the question as seriously as they did. Let me take you somewhere unexpected, because I think the most striking illustration of this entire problem comes not from ancient history or alternative science, but from one of the most mainstream and well-funded areas of contemporary research. NASA has known for decades that long-duration spaceflight damages the human body in ways that are not fully explained by microgravity and radiation alone. Astronauts returning from extended missions on the International Space Station show neurological changes, cardiovascular changes, and visual impairments that persist long after return to Earth gravity. The visual impairment is particularly strange. Some astronauts experience a permanent flattening of the eyeball and changes in the structure of the optic nerve that do not recover. The mechanism is not fully understood. Part of the research into this problem has focused on something called intracranial pressure, the pressure of the fluid surrounding the brain, which increases in the absence of gravity and is suspected of causing some of the structural changes. But the search for solutions has pushed researchers into territory that is adjacent to, and in some cases directly relevant to, the questions we've been asking. Because what researchers found, somewhat to their surprise, is that Earth's magnetic field is apparently doing something important for the long-term health of organisms that evolved within it. Organisms removed from the normal geomagnetic environment. As happens when you're in an aluminum tube orbiting a few hundred miles above the surface, show biological changes that go beyond what the absence of gravity and the presence of space radiation can fully explain. The magnetic environment that the organisms evolved in appears to be functionally important in ways we did not anticipate. This finding has received relatively little attention outside the space medicine community because its implications are uncomfortable. It suggests that Earth's magnetic field is not just a passive shield against solar radiation, but an active environmental input that biological systems have evolved to depend on. Which means that changes in the magnetic field, including the kind of changes associated with geomagnetic storms driven by solar activity, are not neutral events from a biological standpoint. They are disturbances to an environmental input that organisms have been calibrated to for hundreds of millions of years. The long-term evolutionary calibration of biology to the geomagnetic field is not something that has been seriously incorporated into our thinking about either human health or the broader biological impact of solar geomagnetic variability. It should be. The fact that it hasn't been is a gap in our understanding whose dimensions we can barely measure because we don't know what we're missing. There's a research program at a major European institution operating for the past 2 decades that has been doing something quietly remarkable. The team maps the correlation between geomagnetic field strength and measurements of human cognitive performance across populations. The work is methodologically careful. It controls for obvious confounders, and what it finds consistently and across multiple replication attempts is a small but statistically significant correlation between periods of geomagnetic disturbance and reduced performance on tasks requiring sustained attention and working memory. The effect size is not dramatic. We're not talking about geomagnetic storms turning people into zombies. We're talking about a shift of a few percentage points in population-level performance on standardized tests in the direction of impairment during periods of elevated solar geomagnetic activity. The effect is comparable in size to the cognitive impairment associated with mild sleep deprivation. Most people don't notice it in their daily lives, but at a population level, a few percentage points shifts real-world outcomes, medical error rates, decision quality in high-stakes environments, the quality of judgment in rooms where important decisions are made. The research team published their findings. The work was not widely picked up. The reason is familiar by now. Now let's talk about something that connects all of these threads in a way that is both purely scientific and deeply strange. The cosmic ray flux. Cosmic rays are high-energy particles, mostly protons, that stream through the galaxy from sources including supernova remnants and active galactic nuclei in distant parts of the universe. They hit Earth continuously. They are partly deflected by Earth's magnetic field and partly blocked by the atmosphere, but enough get through that at any moment. Cosmic ray particles are passing through your body, right now, several hundred per second. Cosmic rays are not entirely harmless. They are one of the significant radiation sources that cause mutations in DNA. a contribution to the background mutation rate that drives evolution. They are also one of the reasons high-altitude airline pilots have slightly elevated cancer risk. At ground level, the dose is low enough that its direct health effects are negligible for most purposes. But cosmic rays do something else that has attracted significant scientific attention in recent decades. When they hit the upper atmosphere, they produce ionization cascades, showers of secondary particles and ions that extend from the upper atmosphere down toward the surface. This ionization affects the atmospheric chemistry. It contributes to the formation of aerosols that serve as cloud condensation nuclei, the tiny particles around which water vapor condenses to form cloud droplets. More cosmic ray ionization means more condensation nuclei means potentially more low-level cloud cover. Low cloud cover reflects sunlight back into space. More low cloud cover means cooler temperatures at the surface. Less low cloud cover means more solar energy reaches the surface, and temperatures are warmer. Here's where the solar system connection becomes direct. The cosmic ray flux reaching Earth is modulated by the solar wind. When the sun is more active, the solar wind is stronger, and the stronger solar wind deflects more cosmic rays before they reach Earth, resulting in less ionization, fewer condensation nuclei, less cloud cover, and warmer temperatures. When the sun is less active, the solar wind weakens, more cosmic rays reach Earth, more clouds form, and temperatures cool. This is the proposed mechanism behind the cosmic ray climate hypothesis, associated most prominently with Danish physicist Henrik Svensmark. His experimental work at major European physics facilities has produced evidence that the ionization mechanism actually works, that cosmic rays really do influence cloud formation in the way the hypothesis predicts. The experimental evidence is not conclusive. The magnitude of the effect in the real atmosphere remains controversial, but the mechanism is real, the evidence is genuine, and the debate about its importance for climate is scientifically active. What does this have to do with planetary alignment? If planetary configuration modulates solar activity, as the minority of solar physicists argue, then planetary configuration modulates the solar wind, which modulates the cosmic ray flux reaching Earth, which modulates cloud formation, which modulates surface temperature. The chain runs from the positions of Jupiter and Saturn, through the Sun's behavior, through the solar wind, through cosmic ray deflection, through atmospheric ionization, through cloud cover, to the temperature of the air and the amount of rainfall at the surface of this planet. Each step in that chain is, individually, scientifically supported to varying degrees of confidence. The solar cosmic ray link is well established. The cosmic ray cloud link is contested but experimentally supported. The planetary solar link is controversial but has credentialed advocates. The idea that these three steps form a continuous chain from planetary position to Earth's surface climate is not something anyone in mainstream climate science wants to hear, because it introduces a variable into climate modelling that is both enormous in principle and extremely difficult to quantify. But difficult to quantify is not non-existent. And a chain of individually supportable mechanisms leading to a plausible conclusion is not astrology. It is a hypothesis that deserves serious investigation. The fact that it hasn't received that investigation is one of the clearest examples of how institutional boundaries between scientific disciplines and the social dynamics around which questions are safe to ask can leave entire mechanistic pathways sitting in the dark. There's a deeper version of this question that I want to get to, because I think it's the most important one, and it's the one that the ancient skywatchers were circling around without the vocabulary to name it directly. The question is about whether the solar system has structure in a stronger sense than we usually mean. When physicists talk about the structure of the solar system, they usually mean the orbital architecture. Which planets are where, what their masses are, how their orbits are configured. This is interesting and beautifully complex, but it's essentially a description of positions and motions. It's geography and kinematics. What I mean by structure in a stronger sense is something more like, are there stable patterns in the solar system's behavior that are not just the result of gravity solving an equation for current initial conditions, but that reflects something about the solar system as a coherent, organized system that has been shaped over billions of years toward a particular configuration? The conventional answer is that the solar system's current state is the result of gravity acting on whatever initial conditions were present when the system formed. It is organized in the sense that gravity sorts things out, pushes unstable configurations towards stable ones over time, clears resonant gaps in the asteroid belt. but it is not organized in the stronger sense of having been shaped toward any particular purpose or pattern. However, there are physicists who study the dynamical evolution of planetary systems who have noted that the solar system is surprisingly stable in ways that their models have difficulty fully accounting for. The long-term stability of the planetary orbits over the full age of the solar system requires what one prominent dynamical astronomer described as a degree of fine-tuning in the initial conditions that seems unlikely to have occurred by chance. Small perturbations in the starting positions and velocities of the planets would, in many cases, have led to outcomes that destabilize the system. A planet ejected into interstellar space, an inner rocky planet perturbed into a trajectory that would eventually cross another's. The fact that all 8 major planets are still here, in roughly the orbits they've always had, after 4.5 billion years of mutual gravitational perturbation, is a stability that requires explanation. The conventional explanation is anthropic. If the solar system weren't stable, we wouldn't be here to ask about it. This is true, but not fully satisfying. It tells us our existence selects for a stable system, but doesn't tell us what made the system stable in the first place. The dynamical history of the early solar system was chaotic. There were collisions, ejections, dramatic reshufflings. The current ordered state emerged from disorder. The question of what drove the emergence of this particular ordered state, rather than one of the many disordered states that were equally available, remains genuinely open. Some researchers in the field of systems dynamics have proposed that the orbital resonances between the outer planets played a stabilizing role, that the coupling between Jupiter and Saturn in particular created a kind of dynamical skeleton around which the rest of the system organized. The resonant structure acted as an attractor, a configuration that the system naturally evolved toward and from which perturbations are naturally damped, not by design, not by intention, but by the mathematics of coupled oscillators settling into their lowest energy coherent state. If that picture is right, then the orbital configuration of the solar system is not arbitrary. It is the stable end state of a self-organizing process that selected for coherent resonant coupling over billions of years. The positions of the planets are the solution to a very long dynamical problem, and the solution has structure that reflects the problem's constraints. And if that is true, then a planetary alignment is not just planets arriving by coincidence at the same stretch of sky. It is the coupled system expressing a particular state in its resonant pattern, a state that is related to all the other states the system cycles through, that is connected by the mathematics of resonance to the states that came before and will come after. The alignment is a moment in a pattern. The pattern is old. It is the pattern the solar system has been following since it found its stable configuration billions of years ago. Whether that pattern is meaningful in a human sense is a different question. The universe is under no obligation to organize itself around human significance. But the possibility that a pattern this old, this structurally deep, this physically real, might have effects on the systems that have been embedded within it for the entire history of life on Earth is not a possibility that deserves to be dismissed without investigation, simply because its surface resemblance to astrology makes people uncomfortable. Here is where I want to bring in a voice that deserves much more attention than it has received. Not a fringe researcher, not an alternative scientist working outside the mainstream. A man who spent his career at one of the most prestigious scientific institutions in the world, and whose late career conclusions were treated with the kind of polite inattention that the establishment reserves for respected people who say things the establishment would prefer not to hear. Roger Penrose, who won the Nobel Prize in Physics in 2020, has spent decades arguing that consciousness cannot be explained by classical computational processes in the brain. His argument, developed with the anesthesiologist Stuart Hameroff, proposes that quantum mechanical processes in structures inside neurons called microtubules play a role in generating conscious experience. The specific physics involved is complex and genuinely uncertain. Many neuroscientists think it's wrong. The debate is active. But here's what's relevant to our discussion. If quantum processes in the brain play a functional role, and if those processes are sensitive to external fields in ways that classical brain models are not, then the range of external influences potentially relevant to cognition and consciousness expands considerably beyond what classical neuroscience considers. Quantum systems are notoriously sensitive to their environments. The question of whether the background electromagnetic and gravitational fields of the solar system environment, which fluctuate with solar activity, and therefore potentially with planetary configuration, affect quantum coherence in biological systems is a question that has barely been asked. It is not obviously answerable with current technology. The experiments that would be needed to test it are at the edge of what's technically feasible, but the question is not insane. It follows logically from a set of physics that, while contested, is taken seriously by serious physicists. What it points to is a possibility that is genuinely disorienting if you follow it through. The possibility that the physical environment of the solar system, including the dynamic changes in that environment associated with changing planetary configurations, might interact with the processes that generate subjective experience, not in a crude and deterministic way that removes agency or makes horoscopes real, but in the same subtle, statistical, background noise way that everything else in this chain operates. A gentle modulation of the conditions in which consciousness operates, produced by the gravitational and electromagnetic dynamics of the system we evolved inside. This is not mysticism dressed up as physics. It is a logical extension of taking seriously several well-established physical facts: that quantum processes are sensitive to their environments, that the brain may involve quantum processes relevant to consciousness, that the solar system's electromagnetic and gravitational environment fluctuates in ways that are correlated with planetary configuration. The logical chain is long. The evidence at each step is contested. The conclusion is therefore highly uncertain. But it is a scientific conclusion, held with appropriate uncertainty, not a mystical assertion. The ancient cultures that built their observatories didn't have this chain of reasoning. They had the instinct and the observational record. The instinct that the sky's configuration was connected to internal states, to mood, to clarity, to the quality of judgment in important moments. They built entire mythological systems around giving that instinct narrative form. Some of those systems were profound and others were absurd, but the raw observational content underlying them, the generations of correlation between sky state and human state that drove people to build permanent monuments to the patterns they found, deserves more respect than we've given it. Let me take you somewhere that feels completely different but actually connects back to everything we've discussed, because I think this is one of the most striking pieces of the puzzle and also one of the most underreported stories in contemporary science. For the past decade, a growing number of researchers in the field of plant biology have been studying what they call plant electrophysiology. Plants, it turns out, are not passive. They conduct electrical signals through their tissues in ways that bear striking functional resemblance to the neural signaling of animals. Not identical, but functionally analogous. When a plant is damaged, when environmental conditions change, when it is under stress from drought or herbivore attack, electrical signals propagate through its tissues and trigger biochemical responses at distant locations in the plant. The signal travels. The plant responds to it in ways that are integrated and coordinated rather than purely local. This has been known in broad outline for some time. What is newer and more striking is the finding that plants are sensitive to fluctuations in the external electromagnetic environment. In controlled laboratory conditions, plants show measurable changes in their electrical signaling in response to extremely weak external electromagnetic fields, fields comparable in strength to the fluctuations in Earth's geomagnetic field associated with solar activity. This is not a fringe finding. It has been replicated. It is published in mainstream plant physiology journals. It is not discussed much outside those journals because its implications for questions beyond plant biology have not been pursued. The implications that should be pursued are these: if plants, which have no nervous system and no brain, are sensitive to weak electromagnetic field fluctuations, then the electromagnetic sensitivity of biology is not a specialized adaptation of complex nervous systems. It is a fundamental property of living systems. It is present in the simplest organisms. It presumably extends, with appropriate variations in mechanism and sensitivity, through the entire range of biological complexity, up to and including human brains, which means the entire framework in which we think about environmental influences on biology needs to expand. The relevant environment is not just temperature, humidity, available nutrients, and physical pressure. It includes the electromagnetic environment. The fluctuations in that electromagnetic environment that are driven by solar activity and that are potentially modulated by planetary configuration are relevant to the biology of every living thing on this planet, from the single-celled organisms in the soil to the electrochemical dynamics of human thought. The scale of that statement is large enough that it's easy to dismiss by making it sound ridiculous. But the evidence base for the individual components is real and growing. Plant electrophysiology is a serious field. The electromagnetic sensitivity of biological systems is documented. The solar geomagnetic connection to electromagnetic fluctuations on Earth's surface is established. The planetary contribution to solar activity modulation is contested, but has credentialed defenders. None of these individual claims requires special pleading or the suspension of scientific standards. Their combined implication simply hasn't been synthesized because the synthesis requires spanning multiple disciplines in ways that our research funding and publication structure makes difficult. I want to talk about water, because water is where the most contested and also the most potentially important piece of this story lives. Water is the strangest common substance in the universe. Its anomalous properties, the ones that make it essential to life as we know it, are well catalogued. It's less dense as a solid than a liquid, which is why ice floats. It has an extraordinarily high heat capacity, which buffers temperature. It is an almost universal solvent. It forms hydrogen bonds that give it structural properties no comparable molecule possesses. These anomalies are why water is the medium in which life on Earth evolved. What is less well known outside specialist chemistry circles is that water's anomalous behavior extends into territory that is genuinely not fully explained by current physical models. Specifically, water in biological contexts behaves differently from water in bulk laboratory conditions, in ways that are increasingly well documented and decreasingly well explained by the standard account of water as a collection of simple hydrogen-bonded molecules. Researchers studying what is sometimes called biological water, or interfacial water, the water that exists in close proximity to biological surfaces like cell membranes and proteins, have found that this water forms extended ordered structures that are stable over distances far longer than standard models would predict. The water near biological surfaces behaves almost like a fourth phase, distinct from ice, liquid, and vapor, with its own electromagnetic properties. The ordered water zones respond to light, to infrared radiation, and to other electromagnetic inputs in ways that influence the behavior of the biological molecules embedded in them. This work is published. It is conducted by researchers at mainstream universities. It is also extremely controversial because its implications are uncomfortable. If water in biological contexts forms extended electromagnetic structures that respond to external fields, then the electromagnetic environment in which biological processes occur is not just background noise, it is a functional input to biology. The question of whether fluctuations in the geomagnetic environment associated with solar activity affect those water structures, and through them the behavior of the biological molecules they surround, is precisely the question that the people who discovered the structures have been asking quietly, in the face of considerable resistance. The resistance comes partly from the history of this field. Previous claims about water memory and water structure were associated with work that failed replication, and was subsequently used in ways that embarrassed mainstream science. The association with pseudoscience has made it professionally dangerous to work on the legitimate physical chemistry of biological water, even though the legitimate physics has nothing to do with the discredited claims that tainted the field. This is the pattern again. Legitimate science contaminated by association with illegitimate applications of superficially similar claims. The legitimate science stops being funded. The questions stop being asked. A potential mechanism for a real connection between solar system dynamics and biological processes sits uninvestigated because the political history of the question makes it too uncomfortable to approach. The ancient world had a concept, expressed in different forms across different cultures, of a medium that pervaded the universe and through which celestial influences on earthly events were transmitted. The Greeks called it ether, the Chinese called it qi, the Vedic tradition called it prana. The exact details differed. The core intuition was the same, that there was a substrate connecting the heavens and the earth, through which the configurations of celestial bodies could affect the conditions of terrestrial life. Modern science dismissed this concept correctly, as it applied to the specific mechanical theories the ancient world proposed for how the ether worked. There is no luminiferous ether of the kind that 19th century physics assumed. The Michelson-Morley experiment ended that. But the dismissal was applied too broadly. It was used to close not just the mechanically specific ancient proposals, but the entire class of questions about whether celestial dynamics affect terrestrial biology. The baby went out with the bathwater, and what remained was a scientific framework that considered the solar system a backdrop rather than an active environment. The current moment in several fields simultaneously, plant electrophysiology, biological water research, geomagnetic health correlations, solar climate dynamics, planetary modulation of solar activity, is producing converging lines of evidence that the backdrop is not passive, that the electromagnetic and gravitational dynamics of the solar system environment are inputs to the biological and geophysical systems operating within it, in ways whose full characterization we are only beginning to approach. This is not a return to ancient mysticism. It is not a vindication of newspaper horoscopes. It is a slow, contested, methodologically careful accumulation of evidence that a fundamentally important class of interactions between the solar system and the life within it has been systematically neglected, and that the neglect has costs we cannot yet fully measure because we don't know what we're missing. The 4 planets that lined up in the sky were beautiful. Their beauty is not separate from their scientific significance. The same geometry that made them look like a deliberate arrangement is the geometry that expresses the solar system's resonant structure. The same gravity that produced the alignment is the gravity that has been shaping the system's configuration for 4.5 billion years. The same sun that those planets orbit is the sun whose activity modulates the geomagnetic field in which every living thing on this planet is embedded. These are connections, not metaphorical ones. Physical, causal, gravitational, electromagnetic connections. We see the visual expression of them in the night sky. We live inside the biological consequences of them every day. What we have not yet built is the complete scientific picture that shows how they connect, from the orbital resonances of the outer planets, through the sun's activity cycle, through the geomagnetic field to the functioning of the living systems that evolved within this particular configuration of gravitational and electromagnetic order. That picture is being built, slowly, in the gaps between disciplines, by researchers who are brave enough to ask questions that their institutions would prefer they didn't, and patient enough to do the work carefully in the face of social pressure to stop. There's a question I've been approaching from multiple angles throughout this, and I want to name it directly now, because it's the one that sits beneath all the specific claims about solar activity and geomagnetic effects and plant electrophysiology. It's the question that makes everything else either important or trivial depending on how you answer it. The question is, what kind of thing is the solar system? The conventional answer is that it's a physical system, a collection of masses interacting gravitationally, complex in its details, but ultimately reducible to a set of differential equations. Given perfect initial conditions, fully predictable in principle. The complexity is in the calculation, not in the nature of the thing. There is no more meaning in the solar system than there is in the orbit of a billiard ball. It's just bigger and slower. This answer is the one that most working scientists would give if pressed. It is not a bad answer. It has been enormously productive. The predictive power of orbital mechanics is one of the great achievements of human knowledge. We can track spacecraft across billions of miles using equations that are centuries old. The physical account of the solar system is not wrong. But there is a second answer that is also not wrong, and that has received considerably less intellectual respect. The solar system is an ancient self-organizing system that has been evolving for 4.5 billion years. It began as a rotating disk of gas and dust and has, through a process of gravitational interaction, collision, accretion, and resonant coupling, organized itself into a stable configuration of extraordinary complexity. Life emerged within it. That life has been embedded in its electromagnetic and gravitational dynamics for the entirety of its evolutionary history. The biology of life on Earth is not separate from the physics of the solar system. It is the product of the solar system, shaped by it, calibrated to it, nested within its dynamics, in ways whose full scope we are only beginning to understand. The first answer treats the solar system as a backdrop for the story of life. The second treats it as a participant in that story. The ancient skywatchers, for all the mythological clothing they put on their observations, were closer to the second answer than the first. Not because they understood the mechanism, which they didn't, but because the instinct that the solar system was not merely a backdrop, that it was actively relevant to conditions on the ground and therefore worth watching with great care and over very long time, That instinct was correct. We have built the mechanism half of the picture with extraordinary precision. We have neglected the relevance half with an almost equally extraordinary consistency. The result is a science that knows, with stunning accuracy, where every planet will be at any moment across the next 10,000 years, and does not know whether the pattern of those positions matters for the biology of the organisms living in its gravitational shadow. That asymmetry is strange. It is a consequence of where our tools were easiest to apply, where the problems were most tractable, where the funding structures pointed. It is not a consequence of evidence that the relevance question has a null answer. There are people trying to close that gap. They are not all the same. Some of them are rigorous and methodologically sound and working in peer-reviewed spaces, pushing against institutional headwinds with careful data. Some of them are less careful, making claims that exceed their evidence, borrowing the authority of the rigorous researchers to dress up speculation as science. And some of them are simply wrong, holding on to frameworks that have been tested and failed, unable or unwilling to update. The challenge for anyone who cares about these questions is to distinguish between those categories, to take seriously the rigorous minority work without endorsing the broader field of speculation that surrounds it, to recognize that a question is legitimate without accepting all the answers that have been proposed for it. This is hard. It requires maintaining a kind of dual skepticism that doesn't come naturally, skeptical of institutional consensus that may be shaped by social pressures rather than evidence, and simultaneously skeptical of alternative claims that may be exploiting the legitimate gaps in that consensus. Both institutions and rebels can be wrong. Both can be right. The question of which applies in any particular case requires looking at the evidence directly, which requires having enough background to evaluate it, which is exactly the kind of investment that most people, quite reasonably, don't have time to make. What you can do, and what I'd argue you should do based on everything we've discussed, is hold the question more lightly than the loudest voices on either side want you to. The loudest institutional voices say, the planetary alignment means nothing, the correlations are noise, the ancient observers were superstitious, the mechanism doesn't exist. The loudest alternative voices say the planetary alignment explains everything, the correlations confirm ancient wisdom, the mechanism is certain. Both are overstating their case. The honest answer is considerably less tidy. There are real physical connections between the solar system's dynamics and the conditions on Earth, some of them well characterized and some of them not, and the question of how far those connections extend into biology and consciousness and human affairs is genuinely open and genuinely important, and genuinely not being investigated with the seriousness it deserves. Holding that position requires tolerating uncertainty in a way that is culturally difficult. We are rewarded for having clear positions. We are punished for saying, I don't know, and neither does anyone else, and here's why that matters. But the uncertainty is real. Pretending it away in either direction is not honesty. It is the comfort of a false conclusion preferred over the discomfort of a real question. Let me tell you about a conversation that happened at a conference in Vienna about 15 years ago that has stayed with me because it captures something essential about the state of this inquiry. A session had been convened at a meeting of specialists in solar terrestrial physics to discuss what one of the organisers called the cultural problem with heliobiology, which is the technical name for the study of solar influences on biological systems. Several researchers who had been working in the field for decades were present. The session wasn't on the official programme. It happened in the margin, in the way that the conversations that matter often do. The discussion turned to the question of why the field was so chronically underfunded relative to the strength of the evidence, and one researcher, who had spent 30 years at a major European space agency before retiring, said something that the room received in silence. He said the problem was not scientific. The science was sound enough to deserve investigation. The problem was that the field had a branding problem that it couldn't solve. The moment anyone outside the field heard the words solar influence on human biology, they heard astrology. The moment they heard astrology, they stopped listening. And the researchers who had spent their careers building careful evidence were paying the price for 5,000 years of mythology that had used the same objects to make claims they couldn't support. His point was not that the mythology was right. It was that the mythology had contaminated the question, had made it impossible to approach the question on its scientific merits without first spending your entire credibility budget fighting the association with something that had nothing to do with the science and everything to do with the history of the idea. He was right, and the conversation in that room, among serious people who had spent their careers looking at real data, was about the same question that drives ancient Babylonian priests and modern conspiracy theorists and everyone in between. Does the sky matter? Is what happens up there connected to what happens down here? The ancient answer was yes, absolutely, in ways we barely understand. And we are going to build monuments to tracking it because we know it matters even though we can't fully explain why. The modern mainstream answer has been no, or at most, not in any way that rises above measurement noise, and the question isn't worth serious investigation. The emerging answer from the margins of several serious fields is probably yes, in ways that are smaller and more subtle than the ancient world imagined, but potentially more pervasive and more important than the modern dismissal has allowed, and we genuinely don't know yet because we haven't looked hard enough. That emerging answer is where the interesting work is happening. Not in the popular books that claim the planets control your destiny, not in the dismissive mainstream commentary that treats the question as obviously settled. In the laboratories where plant biologists are documenting electromagnetic sensitivity in cells, in the solar physics groups modelling the gravitational influence of the outer planets on the sun's activity cycle, in the epidemiology literature where researchers are carefully building the correlation between geomagnetic disturbance and health outcomes, in the dynamical astronomy papers where the long-term stability of the solar system's resonant structure is slowly being characterized. The work is happening. It is slow and contested and underfunded and largely invisible to the public because it doesn't fit the narrative of either side of the debate. It is neither the planets are meaningless orbital mechanics nor the planets control your fate. It is something more interesting than both, an investigation into the actual physical connections between a complex organized gravitational system and the biological processes that have been embedded within it for the entirety of the history of life, with no predetermined conclusion about where those connections begin and end. When you looked up at those 4 planets stretched across the sky and felt that something was significant about what you were seeing, you were not being irrational. You were responding to a pattern that is genuinely significant in the physical sense. The geometry you saw is the expression of 4.5 billion years of gravitational interaction. The system whose state it reflects has been shaping the conditions for life on this planet since before life existed. The fact that the full story of how it does that is still being worked out does not make the instinct wrong. The instinct is the beginning of a question, and the question is real. What you are not seeing, and what neither I nor anyone else can honestly tell you, is exactly what that significance amounts to. Whether the 3 geophysical events that followed the alignment were connected to it, whether the ancient observers who watched the same conjunction patterns and built their civilizations around tracking them were picking up on something real or constructing a meaningful order out of noise, whether the chain from planetary position to solar activity to geomagnetic field to biological function extends all the way through, with enough effect size at each step to produce measurable consequences for the organisms living at the end of it. Those questions are open, not because the answers don't exist, but because we have chosen, repeatedly, and for reasons that are more sociological than scientific, not to pursue them with the rigor they deserve. The next major planetary alignment will be visible to observers on Earth in less than a decade. The 5 brightest planets will gather in a much smaller arc of sky than the current alignment, close enough together that you will be able to cover all of them with your outstretched hand. It will be the most geometrically striking alignment in a generation. Astronomers are already noting it in their long-range planning. Somewhere, a researcher in heliobiology is already looking at the date and thinking about what data they might be able to collect if they could get the funding to try. Somewhere, an archaeoastronomer is already checking whether any of the major megalithic structures were built to mark events corresponding to that planetary geometry. Somewhere, a solar physicist who has spent 30 years arguing that the outer planets modulate the sun's activity cycle is quietly watching the models to see what the sun will be doing when Jupiter and Venus and Mars and Saturn and Mercury all gather in the same narrow window of sky. Most of the world will look up, take a photograph that doesn't quite capture it, and move on. But the question will remain. It always does. It is older than writing, older than agriculture, older than the first permanent human settlement. It is the question built into the oldest aligned stones in the oldest landscapes on Earth. into the records of the most careful observers of the ancient world, into the quiet work of the researchers who are building the scientific account that those observers deserved and never got. Does the sky matter? We are still learning the language to answer it properly. The answer, when it comes, will probably be smaller and stranger than what either the believers or the skeptics are expecting. It will not vindicate astrology. It will not reduce to gravity being irrelevant. It will be something in between, something that requires holding the complexity together without reducing it to comfort, a dynamic system, an ancient structure, a subtle influence, a long echo of 4.5 billion years of gravitational conversation, whispering something into the biology of everything that has ever lived on this planet, in a frequency we're only just beginning to tune our instruments to hear. 4 planets in a line, the oldest question in human memory, and we, right now, might be the first generation with the tools to actually start answering it, if we can summon the intellectual courage to try.